If a breaker is tripping after the addition of 8 receptacles, there are several potential causes to investigate. Firstly, consider the possibility of an overloaded circuit. 8 receptacles on a 12/4 wire protected by a 20-amp breaker can handle a maximum of 24 amps, calculated by multiplying 20 amps by 1.2. If the total current draw of all devices plugged into these receptacles exceeds 24 amps, the breaker will trip. Secondly, inspect the wiring for any issues. Verify that all wire connections are tight and secure. It's crucial to ensure the THHN wires used in the conduit are of the appropriate gauge for both the conduit and the electrical load they are intended to carry. Carefully check for reverse polarity or any signs of short circuits in the wiring. Thirdly, examine the receptacles and wiring for physical damage. Thoroughly inspect each receptacle to confirm they are not damaged and that they provide good, solid contact with the plugs inserted into them. Look for any visible damage to the wires themselves, paying close attention to the insulation. Check the conduit for any signs of damage as well. Fourthly, a ground fault could be the cause. Make sure that all the receptacles are properly grounded. A ground fault occurs when current flows through the ground path instead of the neutral wire, and this can cause the breaker to trip. Fifthly, the circuit breaker itself might be malfunctioning. Replacing the existing circuit breaker with a new one of the same amperage rating is a good way to rule out a faulty breaker. A malfunctioning breaker can trip prematurely or, conversely, fail to trip when it should, posing a safety hazard. Sixthly, consider the current draw of the devices that are plugged in. Certain high-power devices, such as space heaters, hair dryers, or power tools, can draw a considerable amount of current and easily cause the breaker to trip, especially if multiple such devices are used simultaneously. To effectively troubleshoot the tripping breaker, follow these steps. Initially, unplug all devices from all 8 receptacles. Then, reset the circuit breaker. Next, plug in one device at a time into each receptacle and carefully observe whether the breaker trips after each plug-in. If the breaker trips immediately upon plugging in a single device, thoroughly check the specific device for a short circuit or any indication of excessive current draw. If the breaker continues to trip even with only a few devices plugged in, systematically check the entire circuit for overloads, underlying wiring problems, the presence of ground faults, or the defective circuit breaker. Confirming proper wire gauge is critical for safety and code compliance. The ampacity of conductors, or the current carrying capacity, is dictated by their size and insulation type, as specified in the National Electrical Code, or NEC. When transitioning from 12/4 Romex to THHN within a conduit, it's essential to ensure the THHN wires are adequately sized to handle the intended load. For a 20-amp circuit, typically 12 American wire gauge, or copper conductors are used, but this depends on factors like insulation temperature rating and insulation conditions. NEC Table 310.15b16 provides ampacity ratings for various conductor types and sizes. When running wires through bored holes in studs or joists, the NEC has specific requirements to protect the wires from physical damage. While minimal stapling was done, ensure that the wires are not subject to abrasion or stress where they pass through the holes. If the holes are close to the edge of the framing members, nail plates might be required to prevent nails or screws from penetrating the wires. Pay close attention to the connections within the junction box in the cellar where the transition from Romex to THHN occurs. Make sure all connections are secure, properly insulated, and made with approved connectors for the specific wire types being joined. Loose or poorly made connections can cause arcing, overheating, and potentially lead to a fire. When using conduit for the THHN wires, adhere to the fill capacity limit specified in the NEC. Overfilling a conduit can lead to overheating of the conductors due to reduced heat dissipation. The NEC provides tables in Chapter 9 that specify the maximum number of conductors allowed in different sizes of conduit. Grounding is a critical safety aspect of electrical installations. Ensure that all receptacles are properly grounded back to the main electrical panel. The grounding wire provides a path for fault current to flow back to the source, causing the breaker to trip and energize the circuit in the event of a ground fault. Check the continuity of the grounding system to ensure it is intact and effective. When troubleshooting, a multimeter is an invaluable tool for diagnosing electrical problems. Use it to check for voltage, continuity, and resistance in the circuit. Voltage measurements can confirm that the proper voltage is present at the receptacles. Continuity tests can verify the integrity of wiring connections and the grounding system. Resistance measurements can help identify short circuits or other wiring faults. If the breaker trips intermittently or seemingly at random, it could indicate a more subtle wiring problem or a nuisance trip. Nuisance tripping can be caused by momentary surges, harmonics, or other electrical disturbances on the circuit. In such cases, consider using a surge protector or a line conditioner to filter out these disturbances. Arc fault circuit interrupters, or FSIs, are designed to detect arc faults, which are a common cause of electrical fires. If the circuit is protected by an FSI breaker, it could be tripping due to an arc fault in the wiring or in one of the connected devices. Inspect the wiring for any signs of damage or loose connections that could be causing an arc fault. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults, which can cause electrical shock. If the circuit is near water, such as in a bathroom or kitchen, it should be protected by a GFCI breaker or receptacle. Test the GFCI protection regularly to ensure it is functioning properly. If the breaker continues to trip despite your troubleshooting efforts, it's best to consult a qualified electrician. Electrical work can be dangerous, and a professional electrician has the knowledge, skills, and tools to diagnose and repair electrical problems safely and effectively. Consider the age and condition of the existing wiring in the old house. Old wiring can become brittle and deteriorated over time, which can lead to electrical problems. If the wiring is very old or in poor condition, it might be necessary to replace it entirely. If the house has knob and tube wiring, it should be replaced with modern wiring for safety reasons. Knob and tube wiring is an outdated and potentially hazardous wiring method that is no longer permitted in new construction. When running new wiring, follow all applicable electrical codes and regulations. The NEC is the primary electrical code in the United States, and it provides detailed requirements for electrical installations. Obtain the necessary permits and inspections for any electrical work to ensure it is done safely and correctly. Consider the future electrical needs of the house. If you anticipate adding more electrical devices or appliances in the future, it might be wise to upgrade the electrical service to a higher capacity. This will ensure that the electrical system can handle the increased load without overloading. Label all circuit breakers clearly and accurately. This will make it easier to identify and troubleshoot electrical problems in the future. Create an electrical panel schedule that lists all of the circuits and their corresponding breakers. Keep the electrical panel schedule up to date and readily accessible. If you are unsure about any aspect of electrical work, it's always best to consult a qualified electrician. Electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself and others from electrical shock and fire. Remember, electricity can be dangerous if not handled properly. If you are not comfortable working with electricity, it's best to leave it to the professionals. A qualified electrician can diagnose and repair electrical problems safely and effectively. Always turn off the power to the circuit before working on any electrical wiring or devices. Use a non-contact voltage tester to verify that the power is off before touching any wires. Wear rubber gloves and eye protection when working with electricity. Never work on electrical wiring or devices while standing on a wet surface. Keep children and pets away from electrical work areas. Be careful when working with ladders around electrical wiring. Maintain a safe distance from overhead power lines. If you see any exposed wires or damaged electrical equipment, report it to the appropriate authorities. If you smell smoke or see sparks coming from electrical equipment, turn off the power immediately and call the fire department. The electricity is a powerful force, and it should be treated with respect. By following these safety precautions, you can protect yourself and others from electrical hazards. The information provided is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician for any electrical work or troubleshooting. Remember to always prioritize safety when working with electricity. If you are unsure about any aspect of electrical work, it's best to leave it to the professionals.